This is a note on the laws of logarithms. First of all, we have log A plus log B is equal to log of A times B, and we can illustrate with that with an example. Say we have log base 10 of 100 plus log base 10 of 1000. Then well, log base 10 of 100 is the power of 10 that gives us 100. Well, 10 times 10 gives us 100, two tens multiplied together. So the power of 10 that gives us 100 is 2. So this is equal to 2 plus the power of 10 that gives us 1000. Well, 3 tens multiplied together gives us 1000, so it's 3. So log base 10 of 100 plus log base 10 of 1000 is 2 plus 3 is 5. And our log law says that should be the same as the log of A times B. So this should be the same as log base 10 of 100 times 1000, which is 100,000. And so the question to ask is, which power of 10 gives us 100,000? Well, 100,000, we count the zeros, that tells us how many tens are multiplied together. We have 5 zeros, therefore that's 10 to the power 5. So the power of 10 that gives us 100,000 is 5. So that shows our law there works. Next we have log A minus log B is equal to log of A upon B. And again, we can illustrate that with an example. Let's say we have log of 10 to the power 5 divided by 10 to the power 3. And then we know that 10 to the power 5 divided by 10 to the power 3 is 10 to the power 2, and according to our law that should be the same as the difference between the logs. Well, first of all, log to the base 10 of 10 to the 5 upon 10 to the 3 is log to the base 10 of 10 to the power 2, which is 2, and that should be the same as log to the base 10 of 10 to the 5 minus log to the base 10 of 10 to the power 3, which we can see is true because the power of 10 that gives us 10 to the 5 is 5, minus the power of 10 that gives us 10 to the 3, which is 3. 5 minus 3 is equal to 2. The next law that we have is that log A to the power n is the same as n log A. And again, if we can illustrate that with an example, let's say we have log to the base 10 of 10 to the power 3. And then we know that this is simply 3 because the power of 10 that gives us 10 to the power 3 is 3. And our law says that should be the same as 3 if we log the base 10 of just 10. Well, we know that the power of 10 that gives us 10 is 1, and therefore this just equals 3 times 1, which is 3, and so we say the law works. Next we have a rule for change of base. So if we have, for example, log base 7 of 10, the way we'd work that out is to take log the same base, top and bottom, of 10 upon log of the original base, 7. So as long as these are the same base, but we'll just use 10 for convenience, then that would work to give you logs base 7 of 10. So the way to remember this is take the log of the argument of the original log divided by log of the base which sits just underneath. Last point here is not really a law or rule, but just a common sticking point. If we see natural log uses base e, and therefore if we have natural log of e to the power k, we should ask the question, well, which power of e gives us e to the power k? Well, the answer is k, because e to the power k satisfies that definition. The sort of the equivalent in base 10 would be log base 10 of 10 to the power 6. So which power of 10 gives us 10 to the power 6 is simply 6. So whenever we have the base and the argument with a similar value, then the log of that value to the power just collapses to the power that is in the argument.